Welcome to Chapter 13, where we'll be discussing my favorite topic related to quantum mechanics, which is molecular spectroscopy. And the reason I love molecular spectroscopy is that this is how we actually observe quantum mechanical properties in real chemical systems. Obviously we can't, though in recent years this has actually been done, we can't look at molecules one at a time and see their orbitals. Though that has changed in recent years using specific types of electron microscopy and atomic force microscopy, scientists have actually mapped out molecular orbitals of single molecules, which is really awesome. But in general, we can't do that for most molecules, and even to do that required cooling things down close to absolute zero and using very specialized equipment. So instead, our main way of being able to observe quantum mechanical properties is using light. And so basically what we're doing is using light to measure molecules. And this is how we know it. You remember from the very beginning of the semester, a lot of the properties of the things that the physicists didn't understand at the beginning of the 1900s related to light, blackbody radiation, the hydrogen atom spectral lines, and photoelectric effect, right? All these things involve light. And so, drop my pen. And so it's this interaction between light and matter that really tells us about quantum mechanics. And so chapter 13, we're skipping chapter 14, and chapter 15 are about how that interaction between light and matter. Chapter 13 is a lot of related to, taking the models that we've talked about in our class and how do those map onto spectra, and particularly what are the adjustments that we have to make. So, we've said that these models aren't perfect. So we're going to be using the models of specifically the harmonic oscillator and the rigid rotor as models for our molecules that we're looking at. So in the next video, we'll talk about how we can use different types of light to measure different types of energies in molecules.